Alright, we're going to take a look now at solving systems of equations algebraically. Alright, now you might remember a system of equations are two equations, for example y equals x plus 5 and y equals negative 2x minus 1. Those are two equations, both happen to represent lines, and if we sketch the graph here, we got y equals x plus 5, looks something like that. Y equals negative 2x minus 1, looks something like that. You notice those lines cross in one spot. We can solve these systems algebraically to figure out exactly where they cross without having to resort to graphing or using technology. There were two methods that we used to solve linear systems of equations. One was substitution, the other was elimination. When we're dealing with linear systems and conics, though, our primary method of choice is going to be substitution. Alright, so we're going to use substitution. Alright, and when you solve a system using substitution, you need to isolate the variable in one equation and substitute into the other equation. Alright, so we're going to take a look at these two linear equations. We're lucky because we've already isolated one of the variables. We've got y is equal to x plus 5, and so we're going to substitute equation 1 into equation 2. Alright, so equation 2 says y is equal to negative 2x minus 1. Instead of this y, we're going to rewrite x plus 5. So we get x plus 5 is equal to negative 2x minus 1, which gives us 3x is equal to negative 6. Right, adding 2x to that side and subtracting 5 to the other side. Dividing both sides by 3, we get x is equal to negative 2. That tells us that the x-coordinate where these two lines cross is negative 2. To figure out the y-coordinate, we substitute our value of negative 2 into one of the equations. Negative 2 times negative 2 is 4. 4 minus 1 is 3. So our lines cross at negative 2 and 3. Alright, this is a solution of a linear system using substitution. We're going to be taking a look at linear and quadratic systems. So here we go in example 6. It says solve the following system of equations algebraically. 3x plus y is equal to negative 9. Alright, that's a line. And 4x squared minus x plus y equals negative 9. That's a parabola. Now, when solving a line in a parabola, maybe you've got a line and a parabola, they don't cross at all. Maybe you've got a line and a parabola and they touch exactly once. Or maybe you've got a line and a parabola and they cross 2 times. We don't know starting out. We could have 0, 1, or 2 solutions to this system. As we proceed, we'll see. Alright, now we need to take a look, and I'm going to always suggest isolating the y value in your line is probably the best substitution method you can do. So let's take a look. We're going to transform our line to y equals negative 3x plus 9, or sorry, negative 3x minus 9, subtracting 3x from each side of the equation. And we're not going to do anything to our second equation. 4x squared minus x plus y equals negative 9. Alright, I always try and get into a habit of writing both equations down whenever I do my transformation. Alright, now that I've got y isolated in one equation, I can substitute it into the second equation. So I'm going to take equation 1 and put it into equation 2. So we have 4x squared minus x plus, instead of y, we're going to be writing negative 3x minus 9 equals negative 9. And so now we can treat this as a simple quadratic equation. We've got 4x squared minus 4x minus 9 equals negative 9. This is a quadratic equation, so we have to make it equal to 0 in order to solve it. Adding 9 to each side, we see we get 4x squared minus 4x equals 0. Next, we're going to factor it, it looks like. I can take a common factor out of 4x. 4x squared divided by 4x leaves me x. 4x divided by 4x equals 1. And so you can see we get two solutions. This first gives us 4x equals to 0, or x equals to 0. The second factor gives us the solution, x equals 1. Right? The final step in this is, it looks like we're going to get two solutions. Our line is going to cross our parabola twice. Once when x is equal to 0, once when x is equal to 1. We need to find the associated y values that go with these two solutions. So let's go up here. We've got x equals 0 and x equals 1. And let's use our linear equation, 3x plus y equals negative 9. 3x plus y equals negative 9 to figure out our y coordinates. Alright, so we get y, when x is equal to 0, we get y is equal to negative 9. When x is equal to 1, we get y is equal to negative 12. So we got 0, oops, sorry. We get y equals, or x equals 1, and y equals negative 12. So, the line and parabola cross at 0 and negative 9, and 1 and negative 12. So in summary, to solve systems of parabolas and lines algebraically, we're going to use the method of substitution. Right, the method of substitution says that you should isolate one of the variables in one of your equations. It's usually best to isolate the y variable in the linear equation. Right, and then you substitute. Sometimes you'll get two solutions, sometimes you get one, sometimes you get none. Once you figure out your two solutions, you need to figure out the second coordinate and then write where the lines cross.